Hello everyone. In the previous video, we have seen about Pandas library. So we already know that Pandas library is used for loading various types of data and performing data preprocessing operation. But there is a limitation of Pandas library. Like it is only applicable for small types of data. Like let us say data less than 1 GB. So what happen if we have more data like 10 GB of data or 100 GBs of data? Then at that point of time, what you can do? So here we come up with a solution. The solution name is Polar's library. So Polar is a library which is capable of handling large types of data. So first of all, in order to use Polar's library, you have to write like this: pip install Polar's library. Then click on Shift Enter and it will install Polar's library into your system. After that, what you have to do, you have to install one more library which is the dependency of Polar's library, which is called as PyArrow. So pip install PyArrow. Let me run this out. And this library is downloaded. The dataset that we are going to use in this project is taken from Kaggle. So this is the link of the website where we have taken the data. So the data consists of e-commerce behavior data, and the file size is around, one file is of 9 GB and another file is of 5.67 GB. So we are going to use this October data. So first of all, what you have to do in this, you have to import all the required libraries and then you have to load your data set. So let me write down all my libraries that we need. So first of all, we need Polar's library. So import Polar's as PL. Remember one thing, its syntax is similar to Pandas library. So there will be very less difference as if you compare the syntax of Polar's with Pandas. Next, we have to import PyArrow library, which is used for saving the data in a big data format. After that, I am going to use one more library, which is NumPy library. So import NumPy as NP. Then I am going to import some common data visualization library like Seaborn and Matplotlib. And Matplotlib. So import matplotlib.pyplot as PLT. Now let me run this out. Next, let me load my data set. So df equal to pl dot read underscore csv. So let us check where my data set is present. So here we can see my data set is present in dataset folder. Let me copy this thing. So it is present inside dataset folder and the name of the file is 2019 october.csv. Once we have loaded the dataset, next what we have to do, we have to use the head function in order to display the top 5 rows of the dataset. You can see it is loaded. If you perform the same operation using Pandas library, it will take a lot of time. Now here you can see these are the columns which are present in our data set. So if you want to check the shape of the data set, you just write df.shape. The shape function will show you the number of rows in your data set. So in our case, it is having around 42 million rows something. So we have 42 million rows and 9 columns in it. If you want to convert this thing into Pandas, you can easily do that with the help of two Pandas function. So what you have to do, you have to write like this: df.head dot 2 underscore pandas. So with the help of this function, you can easily convert your polar data frame into the pandas data frame. Now let us see some of the common operation which you can do with respect to this dataset. First of all, if you want to check for the missing values, we can use this command df dot null underscore count. So what this function will do, it will give you all the missing values, all the count of missing values. So here we can see in the category code and in the brand, we have some missing values. Similarly, in user session, we have some missing values. Next, if you want to check for the duplicate rows, you can easily do that with the help of df dot is underscore duplicated dot sum function. With the help of this thing, you can check for the duplicate rows in your data set. So you can see that it is checking for the duplicate values in the data set. Next, we can see here that the data set contain 48,319 duplicate rows present. Now, if you want to convert this event time column, you can also do that. So let me convert this column into date time format. So what I can do, I can write like this. df dot with underscore columns, and then I'm going to select my column. So pl dot col, and here is my column name. So my column name is basically event underscore time. And I'm going to convert into string date time. So I will write dot str 2 underscore date time. After that, I will write the format here. So you can see it is written like this: %y dash %m %d, then hour, minute, second, and the UTC format. So let me just write like this: %y hyphen %m hyphen %d hyphen %h hyphen %m colon %s, then we have %z. So this is how you can convert it out. Now let me save it in a variable name as df. So df equal to this. Okay, so here there is syntax error. So instead of %y, let me make it a small case. Okay, so basically we have to put everything in the double quotes. So let me do that. And you can see it is converted into date time format. You can verify that by using the head function. You can see now it is converted into date time format. Similarly, if you want to perform some operation, like you want to calculate average price per band, you can easily do that with the help of Polar's library. So simply what I can do, I can write like this: df dot group underscore by my column name. Let us say my column name is brand, and I want to aggregate it on the basis of, average price. PL dot call. Here I am going to specify my price column, and then I will call my mean function. So this is how you can calculate average price per band. Let me run this out. Internally, what is it is doing? It is doing the computations. So that's why it is taking the time. Because if we see the size of the data set, the size of the data set is around 6 GB. So here we can see we have price, average price per band is reflecting it out. Similarly, you can perform several other operations, such as if you want to save all the things in a data file. So what you can do, you can just write your data file df.write.csv pd.csv. So with the help of this command, you can save your data in this file format. So these are the various, okay, so here we have write_csv. So these are the various functions which are available in Polar's library. Now, in overall conclusion, we can say that Polar's library is gaining so much popularity in the case of large data set. Like most of the data scientist and data engineer, even the machine learning engineer, utilizing the Polar's library to perform the data processing.